So a linear equation is an equation of the form y equals mx plus b. This equation is said to be in slope-intercept form. In the equation above, m represents what we call slope. Slope is another way of saying the rate at which something changes. If you create the ordered pair 0, b, that point represents what we call the y-intercept. In word problems, this can often be thought of as the starting point. And then x represents our input or independent variable, and y represents our output or dependent variable. Let's look at another example. It says Mr. Quan takes the bus to get to the Highline College campus. He has an Orca card that has $99 on it. The bus fare is $2.75 one way, so that means that he ends up spending $5.50 per day on bus fare. How long will it take before Mr. Quan runs out of money on his Orca card? Assume that Mr. Quan doesn't add any additional money to his Orca card. So there's a lot of information there. How are we going to go about tackling this question? Well, we know that on my Orca card, I have a total of $99. And I know that each day I am spending $5.50. So maybe it would be helpful if we made an input-output table. So what would our input represent? That would be the number of days. And our output would be remaining amount on Orca card. And if you don't know what an Orca card is, it's just like a plastic card that you can load with a balance of money to take public transportation in certain parts of Washington state. So after 0 days, I haven't used any money. I'm still going to have the $99 on it. And after 1 day, I'm going to subtract $5.50 from the $99. So if I did that subtraction, I would get $93.50. And if I go an additional day, then I would subtract another $5.50, which would bring me to $88. But this is kind of tedious. I don't want to keep subtracting $5.50 a bunch of times until I get to 0. That might take a while. So essentially what I'm doing is I want to figure out how many number of days it's going to be until this value on the right-hand side of our table ends up being $0. So what's a better way of going about doing this? Well, I know that each day I am spending $5.50 and I'm starting off with $99. What if I took the $99 and divided it by $5.50? So if I throw that into my calculator, I end up getting 18. What do you think that number represents? Take a moment and pause the video and ask yourself, what's the significance of the number 18? So what that statement in this box here, what that is saying is that if I took $5.50 and I multiplied that by 18, that would give me $99. So essentially what that's saying is that I could use up my Orca card amount for 18 days and then it would finally reach 0. Okay, so hopefully that part makes sense and I'll write a quick sentence to illustrate that idea. So it will take Mr. Quan 18 days to use up his funds. Okay. Part B says create an equation that models the situation above. So recall from up above that the equation of a line is given in the form y equals mx plus b. So here in our table, the input is x and the output is y. So the remaining amount on the Orca card is equal to y equals, well, m is our rate of change, so our constant rate of change, and every day we are losing $5.50. So our slope in this scenario is going to be 5.50. X represents the number of days, and then the B value is related to our Y-intercept. And I said earlier that most times in word problems, the B value kind of represents where we're starting off at. And in this case, we're starting off with $99. Okay, so if we created this equation correctly, if I plugged in an X value from our table, it should give us the proper Y value. Let's do a check to see if that is in fact the case. So maybe I will plug in 2. So if I do that, I would get y equals 5.50 times 2 plus 99. And if I simplify that, 5.5 times 2 is 11 plus 99. And if I add those together, that is $110. Something's kind of fishy. If we had done that correctly, if I plugged in 2 days, my output should be $88. Can you think about what we might have done incorrectly? If you said, Mr. Quan, the slope needs to be negative because the values on our Orca card are decreasing, then you would be correct. So our slope is actually negative 5.50x. So this is the correct equation here. But let's, just for good measure, let's go ahead and check again. So let's do our check for this one. So I'm going to plug in 2 again. So I'd have negative 5.50 times 2 plus 99. And if I multiply negative 5.5 times 2, that is negative 11 plus 99. And if I do negative 11 plus 99, that will give me 88. And so I put a green check mark there because that is the value that we wanted here. So again, the equation in the red box is the correct final equation that models this word problem. All right, part C says sketch a graph of the scenario above by plotting the y-intercept and the x-intercept, then connecting those points. We haven't formally defined x-intercept, but one way that you can think about it is the point at which our graph crosses the x-axis. So I'm going to scroll down a little bit so I have a little bit more room, and I'm going to draw my vertical axis and my horizontal axis. And so our x-axis, we can say that that is the number of days. And our y-axis, or our vertical axis, we could say that represents the total amount of money on our Orca card. Okay, and we know that we start off with $99 on our Orca card, so I'm going to kind of just sketch this and go by 20s. And then we know that it takes 18 days for our money to run out. So on our x-axis, I'm going to go by 3s. So 3, 6, 9, 12, 15, and 18. I'm not going to lie, when I said 3, 6, 9, I was thinking about that song I think it says like 369, damn, you're fine, something like that. Anyways, our Y-intercept, we know we start off with $99, so that's just under 100, and that's the point 0, 99. And then our X-intercept here is the point 18, 0, because after 18 days, we have $0 left, amount left. And I'm just going to go ahead and connect those 2 points now to represent our line. I'm going to draw it with green, so it's going to look something like that. And why does this line help us? Well, if we wanted to know, let's say we wanted to know how much was on our Orca card after 9 days, we could go up here and then read it off the graph, although unfortunately this isn't the most clear. It looks like after 9 days we'll have a little over $40 left, but that's where the equation is handy. So if you wanted, you could say y equals negative 5.5 times 9 plus 99. And then, so if you multiplied negative 5.5 times 9 and then added that to 99, you would see that that is $49.50. So that's how much would be left after 9 days. I sketched the graph, so it didn't turn out the most accurate, but hopefully you get the idea. So that's how much would be on our card after 9 days.